Imagine waking up one morning to discover that decades of dreams, billions of dollars in investments, and the collective hopes of generations of scientists have been wiped away, not by a natural disaster, but by a single line in a government budget. In just a handful of years, the United States could step back from its role as the world's spacefaring leader, not because it must, but because it chooses to retreat. This is not science fiction. Today, more than 40 of NASA's most daring science missions hang by a thread, as a budget crisis threatens to erase the progress that has defined American innovation for over half a century. Let's take a step back and set the stage. Since its inception in the late 1950s, NASA has carried the torch for human curiosity, exploration, and technological achievement. The agency's missions have shaped our understanding of the cosmos, from the breathtaking images of distant nebulae sent by the Hubble Space Telescope to the ancient Martian riverbeds charted by rovers like Spirit, Opportunity, and Perseverance. Each new launch has represented not just a leap for science, but a statement about what a nation, and by extension humanity, can accomplish when it dreams big. During the Apollo era, NASA's budget soared to heights never seen before or since. At its peak in the late 1960s, more than 4% of the entire federal budget was dedicated to reaching the moon. That surge of funding ignited a technological revolution. The same research that took astronauts to the lunar surface also helped invent microchips, satellite communications, and countless spin-off technologies still in use today. It was an era when science was a national priority, and the world took notice. But that golden age faded. By the 21st century, NASA's share of the budget had shrunk to well below 1%. Even as the complexity of missions grew, the resources available began to dwindle. Fast forward to the present. For the fiscal year 2024, NASA's total budget stands just shy of $25 billion, a nearly 2% drop from the previous year. More alarmingly, the Science Directorate alone is facing a proposed cut of nearly half its current funding, slashing more than $3 billion from the division that manages planetary exploration, astrophysics, and Earth science. The White House Office of Management and Budget has called NASA's current science spending, over $7 billion annually on nearly 100 missions, unsustainable. The administration is urging a leaner, more focused approach, advocating for a dramatic reduction in the number of active and planned missions. The numbers are stark. According to the Planetary Society, as many as 41 missions could be terminated or indefinitely delayed if these budget proposals are enacted. That's not just a third of NASA's science portfolio. It's nearly a generation's worth of research and discovery. Let's put a human face on these numbers. Consider the Nancy Grace Roman Space Telescope, a next-generation observatory designed to probe the mysteries of dark energy and search for new worlds beyond our solar system. Scheduled for launch in as soon as 2 years, the Roman telescope faces a crippling 50% budget cut, threatening to reduce its capabilities or delay its launch indefinitely. Or take the OSIRIS-APEX mission, which is already on its way to intercept the asteroid Apophis, a mammoth space rock that will pass closer to Earth in April of 2029 than many of our own satellites. If funding is withdrawn, the spacecraft could become a ghost ship, drifting through space with its scientific ambitions forever unfulfilled. The MAVEN orbiter, circling Mars since 2014, has been our window into the planet's upper atmosphere, critical for understanding how Mars lost its water and what conditions future astronauts will face. Without continued support, MAVEN may fall silent, its data stream ending before we can answer key questions about planetary habitability. As Bruce Jakosky, a leading scientist from the University of Colorado, warns, canceling ongoing Mars missions and Mars sample return eliminates major efforts to understand the environmental conditions that astronauts will face and to prepare the science for human missions. But the list of endangered missions goes on. The Chandra X-ray Observatory, which has revealed the universe's most energetic phenomena, from black holes to supernovae, could be shuttered after more than 2 decades of groundbreaking discoveries. The European-led Rosalind Franklin Mars rover, which relies on critical NASA-supplied instruments, might never roll onto the Martian surface. Even the venerable Voyager probes, humanity's emissaries to interstellar space, face funding cuts that could silence their faint whispers from beyond the edge of our solar system. This is a crisis without precedent. Casey Dreyer, chief advocate at the Planetary Society, calls it the biggest challenge NASA science has ever faced. We risk losing a generation's worth of discoveries, along with our edge in scientific leadership, he cautions. The ramifications go far beyond pink slips for thousands of engineers and scientists, though those job losses alone would ripple through communities and industries across the country. The impact of these cuts would be felt worldwide. Space exploration today is a global enterprise with international partnerships at its heart. NASA works hand in hand with the European Space Agency, the Japanese Aerospace Exploration Agency, the Indian Space Research Organization, and others on missions ranging from planetary exploration to climate monitoring. If the United States steps back, it sends a clear message to partners and competitors alike. American commitment to the frontier is wavering. Joint ventures like the Laser Interferometer Space Antenna, designed to hunt for gravitational waves, could fall apart without U.S. leadership and funding. Meanwhile, other nations are pushing forward. China has landed rovers on the Moon and Mars, launched its own space station, and is investing heavily in lunar sample return. India stunned the world by reaching the Moon's south pole. The European Space Agency continues to develop ambitious missions, such as the JUICE probe to Jupiter's icy moons. If the United States pulls back, it risks not just ceding bragging rights, but losing the technological edge, scientific partnerships, and soft power that come with being first among equals in space. Let's dig deeper into the numbers. NASA's Science Directorate currently manages nearly 100 active missions, covering everything from climate satellites that monitor our planet's changing atmosphere to small exploratory probes sent to the far reaches of the solar system. The proposed cuts would reduce this portfolio by more than one-third, terminating as many as 40 missions and jeopardizing the jobs of thousands of civil servants and contractors. The loss is not just in hardware, but in human capital. The expertise, experience, and creativity that drive innovation would be scattered, perhaps never to return. And the budgetary pain doesn't end there. The FY 2026 proposal suggests an even deeper cut, almost 50%, potentially terminating 19 active missions in a single fiscal cycle. The OSIRIS mission, designed to measure low-energy gamma rays and study the origins of cosmic explosions, faces cancellation before it even begins. The Habitable Worlds Observatory, envisioned as the next great leap in our search for life, is relegated to minimal funding, its future uncertain. What would these cuts mean for the Artemis program, NASA's ambitious plan to return humans to the Moon and eventually reach Mars? Senator Ted Cruz and other lawmakers are lobbying hard to protect funding for Artemis, but their efforts may not be enough to shield the broader science portfolio. As Congress debates, the clock is ticking. If the axe falls, hard choices will have to be made. Which missions survive, and which dreams are put on indefinite hold? The consequences of retrenchment extend far beyond lost scientific data or canceled launches. Space exploration is a driver of economic growth, technological advancement, and national prestige. The technologies developed for planetary missions often find their way into medicine, materials science, and even everyday consumer products. Climate satellites provide the data that underpin our understanding of global warming, disaster response, and resource management. Cutting these programs is not just a matter of saving money, it's a decision to forgo the benefits that ripple through society for decades. There are also risks we can't afford to ignore. Missions like OSIRIS-APEX and Earth-observing satellites play a key role in planetary defense, tracking asteroids that could one day threaten Earth, and monitoring changes in our climate that impact billions of lives. If these missions are abandoned, we lose our first line of warning against existential threats. In the words of a former NASA administrator, the cost of losing momentum in space science is far higher than any dollar figure on a spreadsheet. It is measured in lost opportunities, missed discoveries, and the gradual erosion of leadership. Yet the story is not over. History shows that public engagement can make a difference. In past decades, NASA missions have been saved from cancellation by passionate advocacy, scientists, students, and ordinary citizens writing to Congress, marching in rallies, and sharing their stories. The Hubble Space Telescope itself was nearly scrapped before launch, saved only after a groundswell of support. If enough people speak out now, it is possible that Congress will intervene, restoring critical funding and ensuring that the next wave of discoveries is not postponed indefinitely. Alternatively, NASA may be forced to adapt to a new reality. With fewer resources, the agency could pivot towards smaller, more cost-effective missions, innovative CubeSats, public-private partnerships, and commercial launches. Private companies like SpaceX, Blue Origin, and Rocket Lab are already changing the economics of access to space. This opens exciting new possibilities, but it also raises tough questions. Will private priorities align with the public good? Who owns the data? Will commercial missions be as open and collaborative as those led by NASA, or could vital discoveries be locked behind paywalls and patents? International collaboration may become both more essential and more fragile. Without robust U.S. participation, other spacefaring nations may step up, pooling resources for joint missions, or they may go it alone, excluding American scientists and engineers. The United States could find itself not just falling behind, but standing on the sidelines as others chart the next chapter of space exploration. What does all this mean for you, the viewer, the taxpayer, the student, the dreamer? First and foremost, it is a reminder that science is shaped as much by economics and politics as by equations and rockets. When budgets tighten, even the most inspiring projects can be shelved. Your voice can matter. Advocacy groups like the Planetary Society depend on public engagement, letters, calls, social media campaigns, to show lawmakers that space science is not a luxury, but a national priority. For young people contemplating careers in science, engineering, or space technology, this moment is a crossroads. The decisions made in Washington today will determine whether the United States remains a magnet for talent and ambition, or whether the next generation of explorers must look elsewhere to pursue their dreams. If you care about climate change, planetary defense, the search for life, or simply the thrill of discovery, understand that these missions are the front line. Let's not forget the broader ripple effects. The loss of international leadership could undermine American influence in global science policy, technology standards, and even diplomacy. Nations that lead in space tend to lead in innovation, security, and economic competitiveness. The choice to scale back is not just about dollars, it is about shaping the world our children will inherit. So, what happens next? Congress holds the keys. Lawmakers must decide whether to restore funding, perhaps targeting specific flagship missions, or to accept a new era of austerity. There are precedents for both paths. In the early 2000s, threatened NASA missions found new life after outcry from scientists and the public. But there have also been times, like the post-Apollo retrenchment, when budget cuts led to a decade of stagnation. The stakes could not be higher. A single decision may shape the trajectory of space science for a generation, or even longer. Here's a little-known truth. The cost of inaction is much greater than any short-term savings. The discoveries lost, the talent driven away, the partnerships abandoned, these are the real prices we pay when we turn away from the frontier. Every canceled mission is a question left unanswered, a warning potentially missed, a generation's aspirations deferred. So what can you do? Stay informed. Educate yourself and those around you. Support organizations that advocate for science and exploration. Reach out to your representatives and let them know that you believe space science matters. The future of exploration, and perhaps of humanity's role in the universe, depends on choices being made right now. If you want to see where human curiosity can lead us, now is the moment to act. Like, share, and subscribe for more deep dives into the crossroads of science, technology, and global power. The universe is vast, mysterious, and waiting.